wearing my coat in here. It's kind of warm in here now, isn't it? It's like, oh my gosh. Are we good? Can I hit the right arrow?
No.
No, not yet. We're not hitting the right arrow anytime soon. Man.
Some kids trying to run at you. Get like a.
Are we right arrow ready? So here's the example that ends all other examples, the mother of all examples, as it were. So we've got a 5 kilogram object sitting on a plane. It's plain to see that that's what we have, yes? Yeah. Yeah. Okay, so here is. Actually, let me put this picture right here. Here is 5 kilograms. Okay. And the first question says calculate the kinetic and maximum static friction between the block and the surface. And notice, why do I say maximum static friction? Because we have no way of knowing what the static friction is. It's just static friction is whatever it takes to keep the object sitting still, and we don't know what a force is being applied to it, right? So the kinetic friction, and our coefficient here, of static is 0.57, and the kinetic is 0.32. Now, if they give you these, or you forget what static and kinetic means, the higher one is always the static, and the lower one's kinetic. In fact, I might argue that you could never have, they could be the same, but you could never have a kinetic higher than the static. Don't think so. It's harder to keep it sliding than it is to start it sliding. No? How would you know? Okay, anyway. So the kinetic friction is we just use this coefficient here, right? So 0.32 times 5 times 9.8. So I'm just doing mu times m times g. So 0.32 times 5 times 9.8 is 15.68. So if this thing is sliding, that's the force that opposes its sliding. If it's sliding and we exert less than that force in the direction that it slides, then it's going to slow down and stop. More than that force, it's going to speed up. We'll do examples of that, right? Okay. The static friction is exactly the same thing. It's mu times m times g, but we just use the static coefficient. So 0.57 times 5 times 9.8. This is 27.93. Ta-da-da. So there's the answer to the first question. Calculate the kinetic. That's what the kinetic is if it's sliding. And this is the maximum that the static can be. Right? It's going to fold. If you give it more friction than that, it'll fold. And be like, oh, can't do it. Okay? So let's suppose the block is at rest. Well, if it's at rest, which friction force applies? Static does, right? Okay? And I exert 13 newtons to the left. So I apply, the applied force is 13 newtons, right? Does it move? Is that enough to make it move? No, its betting limit is $27.93, and you just put $13 on the table. It's just going to raise you. Or it's not going to raise you, it's going to see your 13, isn't it? Never raises you. It never starts to go the other way, right? Okay? So how do you make this thing sit still? Exert a force of what? Which way? 13 newtons to the right, yeah. 13 newtons, right? What if I exert 14 newtons that way? It exerts 14 newtons the other way. What if I exert 25 newtons that way? Is that enough? No. If it were sliding, that would be enough to even speed it up, yes? Right? But it's not sliding yet, so this number still applies. What if I exert 27.92 newtons? No, not yet. 27.94. Yeah, it goes, yeah. This is, okay, I was gambling with my wife's grandma, right? You know? I was trying to, well, I think I was playing like poker or something with her, right? Or blackjack, or I don't know what it was, right? And I'm like, we're playing with like coins, and she thinks that's highly scandalous, right? And I go, Helen, he goes, I got such a good hand. I see yours and I raise you and I put $1 on the table, right? And she goes, oh, Chris, that's silly. And she gives the $1 back to me. And I go, no, you know, I raise you $1. Right? And she says, no, that's silly. We're not going to gamble with that kind of money. Okay, no. She won't even gamble. Come on. Okay, so that's the second answer is that if we exert 13 newtons that way, it's just going to exert 13 newtons the other way to make it sit still, right? It's a limit, and there we have it, right? Okay, so now let's suppose that it's sliding to the right. So let's draw a picture of it. It is sliding to the right. That is how you draw a picture of something sliding to the right. You can tell because it's got like those little motion lines, yeah? There it goes, right? Okay. So if it's sliding to the right, by the way, which way is the friction force? To the left. It always opposes the motion. So if the velocity is that way, the friction force is this way. Which friction force do we want to use? Kinetic. Why? Because kinetic means kinos, comes from the Greek kinos, which means to move. Yes? Yes. Like kinesthetic feeling. It's the motion of it. Yes? Huh? Kinetic energy is the energy of motion, only we don't know that yet. Okay, so yeah, this is going to be the force. So 15.68 newtons is going to be that force. If it's sliding to the right, that's the force, right? Let's see, what does it say? If it's sliding to the right and it accelerates to the right at 4.5 meters per second squared, so the acceleration is 4.5 per second squared, right, to the right. Okay, what other force is acting on it? What force is needed? Well, the other force for sure is going to be some positive force. We don't know what it is. Okay, so we just set it up the way we always set these things up. Okay, we go unknown force minus our friction force, which we calculated. Haven't you done this before? Does this look familiar? Yes. Okay, force minus, and the only difference is that we had to calculate this. Oh, the hardship. Oh, the pain. Oh, the struggle. Right? And then this equals 5 times, because this is still 5 kilograms, right? Times A. And we could solve for, oh wait, A, we know what A is, yes. It is positive. What if it was slowing down? Which way would the acceleration be? What would we do mathematically? It would be negative 4.5. Speeding up this way, right? Yeah. What if it was sliding that way and stopping? Which way would the acceleration be? If it's sliding that way and sliding to a halt that way, which way is it accelerating? To the right. What if it's sliding that way and going faster and faster? The acceleration is to the left. Okay? So everything to the right make positive, everything to the left make negative, including accelerations. Right? And then what does this end up being? 38 point what? 38.18. Does everybody else get that? Yeah. With their calculators? Calculators. Okay, the final question. This is question number 4. If you exert 72 newtons to the right when it's sliding to the right, what is the acceleration? Well, here we go. It is sliding to the right. That's what those little arrows mean, right? And we exert 72 newtons this way. Okay? And this is 5 kilograms. Well, is that the only force acting on it? No siree. What's the other force? 15.68. You never ever use the static friction in F equals ma. Okay? Now what do we do? How do we deal with this? Do we make this one positive and this one negative and go 72 minus 15.68? Equals 5 times, and then A is what we don't know. A? Okay, hold on. You guys are ahead of me. 11.264?